So the next trend we're going to look at is electron affinity. All right, we're going to look at trends in electron affinity going down a group and across a period. Now, we won't spend much time on this one. I won't go into explaining the reason why. I'm just going to state what is going to happen. But first, I have to define what we mean by electron affinity. And it is the energy change that occurs when an electron is added to a gaseous atom. So it's kind of opposite of ionization energy that we just discussed, right? So if you have an atom, M, in a gaseous state, and it gains an electron, it forms an anion, and the enthalpy change for that would be called the electron affinity, all right? Okay, first thing I want to mention here is that the electron affinity values are typically negative, and therefore that means that this process is an exothermic process, right? Because the electron affinity value would be some negative number. The other thing I want to say here is that nonmetals generally have a greater absolute, or I should say a greater affinity for electrons than metals. And therefore, the absolute value of electron affinity for nonmetals tend to be greater than that for metals. In other words, the electron affinity for nonmetals tend to be more negative compared to those of metals, even though they're all negative, all right? And that's because nonmetals, they tend to prefer to form anions, right? So as stated here, the electron affinity generally is more negative or less positive on the right and towards the top of the table. So basically going from left to right, the electron affinity becomes more negative, and going from bottom to top, the electron affinity tend to get more positive, all right? And that's basically all you need to know as far as electron affinity is concerned. I won't go into the reasons why, because it's rather complicated, to be perfectly honest, all right? So this is just a demonstration of the electron affinity values of different substances. And I want to pay close attention to the period 2 values here, starting with lithium, ending with neon. And as you can see, the general trend, there are a couple of exceptions, but the general trend is that the electron affinity becomes more negative. Now, there's a bit of a buck to that trend here from -6 to the -27, but after that, and there's another buck to the trend going from 0 to -141, but after that, basically, it's the same, and it's pretty much the same trend for any period, all right? But it's rather complex, and that's why you have some exceptions to that particular trend, and that's all we're going to say about that, all right? Okay, we're going to stop here, and the next topic we're going to talk about is metallic and non-metallic character, the trends in the periodic table as far as those properties are concerned. All right, until next time.